Hi there guys, welcome back to the channel. So today, since we completed the trees, we are going for the greedy problems. Well, all of these problems are arranged in a way, but I would like to do them differently. Those problems were listed into a list. So we're going to solve them one by one. And I'm planning to complete these in 10 to 15 days. So we can go problem by problem, or we can sort them out in the difficulty order. It's better if we do the difficulty order and so that we can understand the pattern. We can really see the pattern and what greedy really is. Let's go on to the first problem. Since we opened a list, these are all the problems. I guess we don't need this anymore. We can sort them in a difficulty order, and we are doing lead code. Oh, wait a minute. Oh, well, it is giving the list indexes, but lead code 4 for 455 assign cookies. Assume you're an awesome parent and want to give your child some cookies, but you should give each child at most one cookie. Okay. Each child has greed factor index value at their index values, which is the minimum size of a cookie that the child will be content with. And each cookie j has a size of s of j. Okay. If s of j is greater than or equals to g of I, if s of j is greater than or equals to, we can assign the cookie j to the child I, and the child will be content. Child I will be content. Your goal is to maximize the number of your content children, output the maximum number. Okay. So we have cookies of size 1 and 1. If we give 1 to the child with 1 content, or both to the child with 2 contents or 2 content, we will have 2 more children left. We have 3 children and 2 cookies. The greed factor of 3 children are 1, 2 and 3. And even though you have 2 cookies, since their size is both 1, you can only make the child whose greed factor is I. Content, sorry, greed factor is 1. You need to output 1. So from here, greed 1 and 2, and we have cookies of size 1, 2 and 3. So we'll give 1 to G and 2 to 1 to 1 and 2 to 2. You have 2 children and 3 cookies. The greed factors of 2 children are 1 and 2. You have 3 cookies and their sizes are big enough to gratify all of the children. You need to output 2. Number of your content. Well, let's go. So what can we do is, okay, it said there is a similar problem here. Also, we have to see the constants. Length of G and length of S will be between 1 and 3 into 10 to the power of 4, and length of S is 3 into 10 to the power of 4. I is less than or equals to G of I. Okay, I and S will be between 2 to the power of 31 minus 1 to 1. Values are, okay. So if SC, if not S, you have to return 0. Now let's sort G dot sort S dot sort. We sort G and S. P1 comma P2 equals to, actually let's keep P equals to 0 for I in range of G. Actually, in range of length of S, S of I phi G of P, P plus equals to 1. And we have to return P. Let's see. It seems like it is working fine, and I believe this will go good. It will take n log n time to sort them out. 3 into 10 to the power of 4 is good for n log n. But can we do it in a linear way? Well, I guess we can't maybe if they are sorted. Mm, let's submit this and see how this will go. Well, seems like this is working, but it can be optimized, I guess. Let's see the topics. Sorting, greedy, two pointer, and sorting. Let's see what could be done other than this. Let's see other solution as well. Well, they did sorted G and S. They created two pointers I and J. If S of J is greater than K, I plus 1. Didn't I did the same thing? We did the same thing too, but I greater than S. Maybe because we had a condition that needs to be checked every time. Let's ask GPT. Let's take a new chart. Can it be optimized? That's one thing we can do for sure. Now we don't need to search every time. I mean, we don't need to. Let's see anyway. Well, seems like this thing improved a lot. Let's take 23. So it is about half the time. So I hope you guys understood the intuition. It's very simple. We sort the G and S and we created a pointer for the G. Since we sorted it in a ascending order, if we cannot solve the content of the first kid, we cannot solve the content of the second kid. So we need the preceding kid's content to be solved first. So I'm checking if the cookie can solve, since cookies are also ordered in sorted order. We are going through each cookie and see if it can solve the kid's content, and if it can, If it can, then we are going further and we are checking the next cookie if it can solve the content of the second kid, and so on and so forth. If length of p is exceeded, then we will return p here, or if the entire s was iterated and p didn't trigger the g, then we have to return what how many of the, like whatever the number of kids got their content clear, that number. So that's it, guys. I hope you guys understood the inclusion. And this is the edge case, whereas I think we don't even need this, but let it be. It will avoid sorting the both. So I hope you guys understood the inclusion. If you like the video, upvote it and share it with your friends, and don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning and keep pushing hard, and also not forget to leave a comment. It would boost us to give you a more much better content. Thank you for choosing the channel again, and goodbye.